tutorial scikit-learn. There is hundreds or thousands of tutorials that you can find on the internet, so it's very easy to do that. This is something a bit special, which
I find was very important for me particularly when I was managing the team doing data analysis in Python. And the thing was that for example, in GoGovan, we have a data science team and we have a regular meeting that is to our stakeholders. So basically we have analytics meeting where we share insights, we share models, we share some recommendations. And over the time, I could really notice that some things were working really well and really grab attention of people and made some actions based on analysis, and some were working not so well. And we had some issues with some of our analysis, particularly as you have a big team. You can run into issues where someone is using particular definitions, particular format, particular workflow, and then the other person is using different, which makes it a bit harder for end users to understand our analysis, because once he gets the notebook from someone, is used to this and then different ways, so it can be a bit confusing. Also, disclosure, I just landed yesterday night from Europe, so a bit jet lag, and I prepared this presentation during night, consolidating all those thoughts. But those thoughts I've been thinking for a long time, but this was a great opportunity for me to finally sit down and try to put them in one document. So actually what you're seeing right now is really an initial attempt to put all the best practices we are learning as we are doing the analysis in data science team into one document, so that every team member can refer to that and every new joiner can look how we're doing things. This is not finished yet, so this will be like living document. So if you guys see any comments or you have some ideas what should be added here, just please talk to me. I'm sure I will be adding a lot here as well. But let's start. So first part might be a bit boring because it's kind of like an introduction of what is actually analysis. And again, this is actually important because when you have a team of data scientists, it's quite useful to have these high-level guidelines to
maintain the quality of the analysis.
So first of all, I just want to also mention that often the data science is associated with machine learning and all the fancy optimization algorithms and so on. But actually, I think there is much more to data science, particularly even basic providing a simple query and ad hoc request, exploratory analysis, data mining, trying to find some insights and patterns, finally designing, executing and analyzing experiments, building analytics tools and data self-service exploration tools that stakeholders can use, developing statistical models, forecasting and simulating scenarios, building data products, so recommendation engine and stuff like that, and data storytelling and visual presentation. So in this notebook, I am only focusing on the parts here: exploratory analysis, data mining, mainly about those areas. So this probably you have seen, so I can skip it. Okay, and this is the really important slide I want to cover just as a theory. So what is a good data analysis? And I'm sure every one of you have a bit different definition. However, through my experience presenting this kind of analysis, I found that those are some important things. So obviously actionable. So if you do some even the best analysis, super fancy modeling, super fancy slides, if after the meeting there is no actions, you didn't convince anyone, then I think you wasted time, even though it was fun. Timely. This is something also important that I found that the iteration cycle is very important for analysis, meaning that if you can deliver something quicker, you can already make quite a lot of impact even though it's not perfect. I have learned that, for example, in Zynga and Natural Motion, when there's millions of users, if you find some bug through your analysis quickly, even though the analysis is not perfectly formatted, it's not perfect, if you communicate that, you are able probably to save some significant money just because you communicate fast. Also, the good thing about communicating fast is that you get feedback fast, meaning that next iteration of analysis can be even better. Now, this one is an interesting part, pragmatic. This one, I've seen, and myself, I've been guilty of this as well, but I've seen particularly new joiners in data science, particular interns after university, after a Coursera machine learning course or something like that. They come into the team, and the first approach to solve the problem is some machine learning model or some fancy technique, statistical technique. Actually, it's not so often the case that you really need that. In fact, I think that you can, the simpler the solution, the faster the solution, initial solution, the better. And of course, later you can upscale, so you can try something more fancy, you can try things more sophisticated and maybe more accurate. But here I have this approach that you can progress your delivery. Meaning that, let's say if your boss comes in to you and have a question, how would you answer in 5 minutes? If you have 1 hour, how would you answer in 1 hour? If you have 1 day, how would you answer in 1 day? And then 1 week. So that means that for hopefully in each of those steps, you should have a better result. In a way, are they more accurate or more insights and so on, or better formatted, better communicated? But basically, there should be some jump, incremental jump between each. If there is no jump, that means that pretty much this one was enough, and then you could move to other tasks. Clear. This is another part is that it should be easy to understand. Like for example, the way we deliver analysis is we use fully the notebooks. So we used NB-convert to automatically convert the HTML, basically, and then we automatically put it on the dashboards, which we have developed is a Flask dashboards, meaning that you can access, end users can access those detailed notebooks. Right now we have hundreds or maybe even thousands of, probably even more than 1,000 of notebooks. So you can imagine they can be quite intimidating, meaning that some of them they are very long, a lot of code, a lot of definitions, hard to find. So that becomes a challenge for end user, and basically you can scare off end user and for him not to go to your dashboards and not to read your reports, which is not what you want to do. So that's why we try to be very clear, have easy language. Of course, we hide the code cells. You guys know in Jupyter Notebook you can have a slideshow option. You can just hide the cells, code cells and so on when you export. Unambiguous, super important. Again, is, you know, when you have a lot of analysis, at the end of the day, you need to provide some kind of recommendation, meaning that your conclusion is this and this and this. You might have different hypotheses as well, but at the end of the day, you're providing some kind of conclusion, and that's also very important to not contradict yourself in the analysis. This all came out in practice, so I'm not making this up. Actually, every of these points really happens. There can be some issues there. Then consistent. This is super important. So definitions, variable names, column names. This is really about the style and formatting, but it's all about, if we mean active users, everyone thinks the same. You know, you could define active users in 10 different ways. If you mean retention, we have definition of retention in the notebook. Or at least we link to it. So that's again very important. Organize. So the idea is just to have some kind of headers and natural flow to it, so that it's easy to refer. IPython Notebook makes it quite easy. Like you can see, this automatically generates this list of content. In fact, if I change something, it will automatically update. Reproducible, very important for analysis. So I remember when I was in PwC, I used to talk with the forensics team. So especially for forensics team, it's extremely important. Basically, they were asked for a client to do some analysis. They came to the client, and basically they look into financial data, and their conclusion was to fire a number of people. So now imagine if someone would come back later to this analysis, based on this analysis, try to rerun it. They will fire the people, and they go back and say, hey, actually you shouldn't fire them, your analysis is incorrect, right? So obviously we are not so serious in GoGoVan. We are not firing anyone from data science team right now, but however however, it's still very important to have reproducible analysis, meaning that at any given point in time when we can go back, if we run the analysis, hopefully it should render the same results. Delightful. This is a bit additional, but when you can, I think it's good to have some small touches that make it a bit more interesting for end user. And I'm still learning about this. I'm still almost every week I'm finding something we can do to do this. But indeed, you can sometimes see that one sentence, one picture can make a difference of how end users understand. Like, you guys are all, you know, very experienced, you are technical, but it's not always the case with the people who we present to. So that's why it's quite important to put some thought here and make it a bit more delightful and pleasant. Okay, so let's go through some of the points. I might not have time to go through all the notebook, but don't worry, consider it part one of the presentation. So so first of all, notebook setup. This is just again communicating to the team how we're doing this. I think we can skip this, but interesting parts is obviously launch login. Currently in Hong Kong we don't have login, but we have launched in some other countries, and we were tracking whether this has impact on whether actually users complete the order. It has some, but I think it's basically acceptable. Now, so also something that I found, so this is a lot of meta information here, but there will be some code. So also I found that very important in the presentations is also to show the pictures to users. Like, if you're implementing login, how does it look like? It's such a small thing, but actually makes a lot of difference. Like some of the analysts, they would just go directly to the code and a lot of text, and it really is hard for user to visualize. Something also, and this is another our util we have written in Python, something we found that is extremely useful. For example, for example, we often want to optimize completion rate. So there are periods in GoGovan, but also in the whole industry, that, and by the way, for those people who don't know who GoGovan is on-demand logistics. But I know you guys know because you're in Hong Kong. So during holiday, like mid-autumn, our cancel rate would be very high. And this is all across the board. All the companies will have basically the proportion of completed order is very low due to the low supply of drivers and high peak demand of orders. So what we have found that when we talk about those days, it's really good to show it on the calendar, and that's why we developed this util. And this is just some dummy data, but you know, this is such a simple thing. But so many times when we talk about this analysis, people were asking, oh, so which day is it? Which day we need to do this campaign? So even starting, and here you can imagine there would be like actual data of the, for example, previous year. We would show a very high cancel rate, so people would really know that, for example, all across is green and suddenly those days are red. So very, very, very important to focus the discussion. Here, getting the data, again, all our notebooks, I want to have this kind of parameters. So which country, which start and end date, and then basically we just if we query the data in SQL, we just have a SQL directly in a string here, and then it's very simple. We just have this util that just get the data to pandas DataFrame directly. So we can directly in the notebook we can have this. This again is important for reproducibility. So we don't have separately someone downloading a CSV file or doing queries separately and then loading in the notebook. No, because then the whole idea is that you know, our goal really is that if you do this, restart and run all, the notebook should run. So that's the bottom line. Okay, so I will be skipping some parts, and also please let me know in case you are interested in any particular area of this content. Now, some additional info how to get data from the external sources. You know, obviously when you get the data, important thing is to check this data, right? There could be separate topic on this talk on this. So I was not talking too much details, but the obvious things are outliers, missing values, and for example, there is a very handy function I have imported somewhere else, but basically it's called pandas summary, and you can get this kind of output of all the columns in the data frame. This is just for illustration, but you can see in one line, basically you are getting a number of things that you want to really evaluate when you just get the data. So very quick, very easy. Here is some typical processing, like creating new features, and pandas obviously is amazing in that. So you can filter based on some masks. You can extract hour, weekday, and all this kind of stuff. I think I will this standard transformations. You can map the data using some lookup keys. You can join the data in the columns. Extremely powerful. Oh, this is the library I was talking about, pandas summary. Okay, there are some parts. I will go directly to the and of course there are data quality issues, but again this could be a separate topic, so I'll skip through that. And now exploratory data analysis. This anytime we do any analysis, focus on any problem, we will start with EDA, and basically I think you keep doing similar things all the time, right? I mean, if you guys are do data science, you know that EDA is quite similar. So you draw histograms, you draw scatter plots. So if you guys use Seaborn, this is extremely easy. You just use the pair plot, which draws you both the scatter plots as well as the histograms. If you then you can do the correlation plots, so you can see each of the features, how they correlate with each other. Again, very nice Python code. So, and that already, those two charts, those two lines of code, basically sorted a lot of EDA, right? I mean, obviously you can look into more details then and try to go deep, but basically that already gets you quite a long way in just 2 seconds. Style and naming, something I need to add here, but this is all about the first of all adding very explicit names of the variables. So I personally, and you guys can express your own opinion, but personally I prefer if the variable is very long but is explicit, meaning it can be like blah blah underline blah blah underline blah blah underline. It's fine for me because it's autocomplete anyway in the notebook, so I don't care. However, if I read the variable or a column and I don't know what it is, then I assume that end user for sure doesn't know what it is, and that's really annoying, because one, it's not great for us, but also it means that someone will come back and say, hey, by the way, what is it, right? And that's it's still a good situation, because the worst situation is if the end user reads this report and he actually doesn't comment, so he doesn't understand but he doesn't ask, so that's even worse, right? So so that's why very explicit. I always am quite particular about this, and of course like no typos if possible and stuff like that. Now coding, you have whole PyCon conference here on coding, so I'll miss this part, but one thing I only want to say, I personally I love everything that is vectorized. So for a long time when I first was reviewing work of my team, pretty much every time I found some code where they were looping through the data frame. I must say I don't think there is really much situations when you actually need to loop through data frame. Pretty much everything what I've seen you can vectorize. So and this of course make it much easier to debug and understand, and of course it's shorter and better and faster as well, because often it's using NumPy underneath. Aggregations, yeah, you can do some really cool aggregations like multiple functions at once. Okay, this again, this I will just maybe for the part 2 I will talk more, because I still want to show you some charts, but here it could be definitely a separate topic. I think one point I will do a separate talk on this, because it's huge. Like for example, often something what we come across is testing hypotheses. So comparing, we had some intervention, was there a difference or not? Recently we had let's say some negative news in Hong Kong press because of the merger. Only from one, mostly the news were very good. However, there was one article that was negative, and we were looking whether it impacted our order request, and actually impacted us, which is really interesting, because it impacted quite a big way. But actually there was a big challenge to really even coming with this conclusion, because there was a lot of things that were hard to compare. For example, there was typhoon in one of the days, there was some holiday, so you know how, you cannot compare this apple to apple. That's why you need to have either somehow model those effects with multivariate modeling, or some trend seasonality cycles, or have a good counterfactual, and so on, so on. Very, very important, separate topic. And of course, even for the testing, you can use a standard t-test, but it's not always the case that is the right approach, and you should be quite aware of this, because you might get that, oh, there is no difference all the time, but actually there is. Okay. And then this extremely important, review and quality checking. So first of all, when you check the analysis, obviously the common sense before you send it to anyone. I mean, this sounds really obvious, right? So I shouldn't be even, I think, talking about this. But again, through experience, I know all data scientists are very busy. They have a lot of stuff to do, so it's very easy to miss some parts. That's why there's this document. So at least you have some kind of checklist of what to do. So common sense checks, like, can orders be in a million in a day? Can probability be above 1? Like all this kind of standard stuff. Other sources, again, we have already thousands of reports, we have dashboards, we can cross-check some data with different sources. Because again, for data science team, it's very important that we send one message, consistent message. Like imagine if you are CEO of company, and once you get reports saying, oh, sales are down, and from other you get sales are up, who do you trust? You trust no one, right? So so that's not the way. So we need to be cross-checking. Internal checks. This is super cool technique I have learned in PwC. Basically, you can have some just few functions that are aggregating data slightly differently and just doing like a control sums. Meaning that if the number of order requests by vehicle, is it equal by, let's say, by region or something like that. And hopefully the numbers should be the same. There's many things you can do here. You can talk with someone as well, subject matter expert, and you can have unit tests, of course, and stuff like that. Okay, now let me show you some graphs. I have 5 more minutes, so let me show you some. So let me show you some graphs, and this is really some real examples of our analysis. Of course, there's much more. So if someone is interested, let me know. So obviously, you need to label the graphs, very important, and the axis, super important. Okay, one of our cool UTs that we have built is this heatmap metrics. So we built a number of UTs to make repeatable stuff for our data scientists very easy. So actually, this is just one function, heatmap metrics, and it says country, start date, end date, and weather filter our reordering and the metric. But actually, you can see that is it's basically providing all the data for all the days and all the hours in one line that normally it would be very hard to get. And by the way, this heatmap view, extremely powerful. I got a lot of feedback from end users saying they really find this view very useful. And particularly, as you can see, I just had the one. Let me see if I'm not sure if I have imported this. I have microphone, so maybe I don't run. But anyway, if you run the 2 question mark in Python, you actually get the whole implementation of this function with a docstring, so you know what options are available. Again, very important. So there are some other metrics you can pull from this. Now, estimated metrics, and another view of ours, so trying to see what's the current order request for this period. For example, what's the period 1 year back or period back, and then also what we forecast based on some model here. And this again is just one-liner and creates all of this what you see here. Very powerful, because basically you can track over day and see whether we are close to the forecast or not. So very nice pattern for visualizing, because as the days come closer, you can see what's the gap, and we can adjust our prediction. Another visualization cool is about accuracy. So for example, you have a driver's location GPS points. We can say how accurate they are, the GPS, and you can see this differ based on their device, the operator, and the connection type. So this gives you some idea when you actually analyze the data. Another cool visualization we have done is in Python is comparing the order request data with the GPS data, particularly if driver has said that he is doing particular order, we're able to check whether he is actually doing based on GPS, as long as he has GPS open, which he should have. This was interesting and important because one of the time we were doing a special campaign in order to optimize completion rate. And basically you have incentive for drivers. If they complete more than X orders, they will get certain reward. So because of that, we're worried that some drivers will try to create fake orders. So indeed, what we have found that, and this is the same analysis, that you can see there is a driver who should take the order from 1 to 2, and there are some GPS points here. So he never in this time went to pickup location or the delivery destination. And in fact, this flag that you can see here is actually where he said, I completed the order, I resolved the order. So obviously not the case in this case. Here, I think 1 minute, so let me choose something. Yeah, again, a nice way of visualizing the model, evaluating the model, so real unmet demand with predicted. This is, let me see, I think, yeah, obviously the confusion matrix. This is the good way of visualizing the confusion matrix. And something that, and the last one thing maybe, when you do clustering, another good thing to do before you actually decide on the cluster, a number of clusters, is to create this kind of graph, cluster versus inertia, to see where is the, you know, where are the benefits of having clusters. Obviously, if you have maximum number of clusters, it's very accurate, but it's not very useful, because if you have 100,000 data points and 100,000 clusters, that's not very useful. And I think maybe here I will finish on this one. If you guys have any question, please catch me after. I'm sure I will be completing this further and we'll have even more to share next time. Thank you.
Thank you, Michal. Does the floor have any questions? Maybe we could have one or two.
I have a question about how you manage the notebook version. Like, because if it's notebook, you have the same code, but you have different data you run. Like, if I just use something like Git, it's really hard to manage this. So yes. I have a question whether you have a special.
Yeah, it's very, very good question, actually. I've been thinking about this because indeed, the notebook's versioning is so-so, for me at least. Because Git doesn't work very well with notebooks, as far as I know. However, there are some ways. So for example, you can just version the Python code in Git. So there's some way to extract the Python code from the notebook and just version that. So then you can clearly see the difference, for example. Because the main reason for me to versioning the notebook actually is about, if we collaborate, I want to see what was changed by different team member. And that's quite difficult if you have a whole notebook. But if you just version the code, it's possible. So that's one of the approaches. But actually there's some others. So if you Google that, there will be some. But it's not great, I would say. Okay.
Thank you, Michal. So, the coming up session will be conducted in Cantonese, but accompanied by English PowerPoint slides. If you have any questions or problems encountered, please let us know. And there will be another talk next door,
which is how to reinvent the wheel and build the most popular adjacent library by Mr. Kirill Pavlov, which is conducted in English. It will be held in the classroom next door in P4701. If you have